Hello class, welcome to another session of this particular course. Today we'll be discussing about hypervisors and their roles in local virtualization. A hypervisor, also known as a virtual machine monitor, VMM, is a software layer that enables multiple operating systems to run concurrently on a single physical machine through creating and managing virtual machines. In our previous classes, we've discussed about virtual machines. So it's abstract the hardware resources, which are the CPU, memory, storage, and network, and allocate them to the virtualized environment. So we discussed about hypervisor. Now we know the meaning and we know its functionality, what it does. Now, what are the roles of hypervisors in local virtualization? Now, first is resource allocation. These hypervisors manage the distribution of hardware resources among VMS, ensuring efficient utilization. What this implements is the processors is assigned based on the priority or based on the needed, based on the process that needs the processor the most. So ensuring that processes that do not require much more of the processor are ignored, while emphasis are placed on request needing the resources at any given time. Second one is isolation. VMS operate independently, so meaning one VMS failure or activity does not affect others. So Hyper supervisors help to ensure that if one VMS fail, the failure does not affect the smooth operation of the other VMS. Second one is the third one instead is the flexibility. Hyper supervisors allow different operating systems to run on the same physical hardware, making them flexible, reliable, and efficient. Scalability. Organizations also, hyper supervisor help organizations to easily scale up or down by adding or removing VMS. By adding or removing VMS based on demand. So this scalability ensures these resources are distributed evenly among the VMS. So this VMS distribution evenly ensures this organization manage its own resources based on the demands situated within its clients. I'll come again. This scalability aid organization is scaling up and down through helping or ensuring that VMS are distributed based on request. That's what it does. So testing and development. Hyper supervisors enable safe environment for testing software without affecting the whole system. So this environment allows software or system developers to test their system without affecting or without affecting the normal operations of the what's it called? Excuse me, of the software or the environment. So now let's look at the types of VMS. Hypervisors. So hypervisors are categorized into two. We have the type 1 hypervisors, example which include bare metal. In our previous class, I've mentioned 2 or 3 examples on this part. So now let's know what does type 1 does. This run directly on the host hardware, bypassing the operating system. So examples include VMware, EXI, Microsoft Hyper-V, Zen Server, and so on and so forth. So their features include high performance and efficiently, since they operate closely to the hardware. Another thing is they reduce latency and overhead. Also, they enhance security due to limited attack surfaces. So majority of the use cases where this type 1 are applied is an enterprise data centers and cloud, and also in cloud computing platforms. So type 2 hypervisors, which they are known as hosted, this run up on top of the operating system and depend on it for hardware interactions. So unlike the other one that works directly, these ones work directly with the hardware. These ones run on the host operating system and depend on it for the hardware interaction. So example includes VMware Workstation, Oracle VirtualBox, Parallel Desktop. So in this case, the features too include it's easier to set up and use, which makes them ideal for personal and small scale use. Two, compatibility with various host operating systems. So it's compatible across various platforms, which include Windows, macOS, and Linux. It is also, or they are also slightly higher overhead compared to Type 1 due to reliance on the host OS. So their use case scenarios include software development and testing and education and personal virtualization. Now, let's look at the popular hypervisor platforms, their features and the capabilities. VMX Type 1, which is an example of a Type 1 hypervisor, is enterprise-grade virtualization platform. Some of the key features include the robust management tools via vCenter, high availability and fault tolerance, and it supports a wide range of operating systems. The Microsoft Hyper-V, which is also another example of Type 1, can be integrated into Windows Server OS. Key features include seamless integration with Windows environment, and it also supports live migration for minimal downtime or to minimize downtime. It's also strong compatibility. It has strong compatibility and with a Microsoft Cloud Service Azure. So Zen Server 2, which is also another example of Type 1, is also an open source hypervisor which is used in cloud environments. So its key features include it's flexible and customizable, meaning you can customize based on specific needs. And it also supports high performance for virtualized workloads. And it's also has advanced security features with Zen project. So continuously, these are examples of Type 1. So now let's look at some examples of Type 2 hypervisors. So number one, we have the Oracle VirtualBox, which is an example of Type 2. It is an open source hypervisor that is suitable for both personal and professional use. Some of its features include wide OS support. It supports wide range of operating system. It is also rich. It has rich set of network options. It can allow connectivity of varieties of network. Similarly, it is also free and lightweighted, meaning it's not heavy. It's small in size. So another example of Type 2 is Parallel Desktop, which is a Type 2 hypervisor. It is popular amongst Mac OS users. And some of its key features include optimized for running Windows on Mac OS. It allows Windows to run on Mac OS. And it has high performance graphics for gaming and design applications. This allows gaming to happen on Mac OS and also allows designs of good or enormous applications. And it is also seamless in terms of integration with macOS features like Touch Bar and so on and so forth. So this now brings us to the end of this class. So in our previous class, we talked about hypervisors. Now we know what hypervisor is, the different types of hypervisors. We also look at some examples of these platforms of hypervisors. But in particular, we look at the most popular platforms, their features, and their capabilities. So for this class, there won't be any quiz. So let's meet in the next class. For now, bye-bye.